Myself, Ketan M. Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Department is Electrical Engineering Department. And subject is Testing and Commissioning of Electrical Equipment, 4th year, 8th semester. Chapter number 1, Testing of Transformer, Plant and Equipment. Okay. First, today's topic are no load losses or no load current, load losses or short circuit losses, and insulation resistance maker. Okay. First of all, no load losses or no load current. In exams, explain the significance of the load excess, load losses or short circuit losses of power transformer, the method of short circuit test or no load test. Okay, this is the figure of no load losses. This is current transformer CT. Okay, this is ammeter, this is a wattmeter, this is a voltmeter. Okay, and this is a transformer under testing. This is X1 and X2 terminal, and this is H1 and H2 terminal, LV winding and HV winding. Okay. If the secondary winding is short circuited, okay. 1 minute. If under no load condition, the transformer takes no load currents. Okay. No load current is less than 4% of full load current. Hence, I square R loss or you can say copper loss are negligible under no load condition. However, the iron loss or you can say hysteresis losses or eddy current losses are present during the no load conditions. No load test is a routine test and should be performed on every transformer manufactured by a manufacturer before dispatch. No load test on transformer is performed at normal voltage and normal frequency with HV winding left open. The LV winding is supplied with normal 3-phase rated voltage of rated frequency. The input power is measured by 2 wattmeter method or by 3 wattmeter method. The input power gives no load loss. The input current gives a no load current called magnetizing current. The value of no load current and no load losses are useful in evaluating the performance of the transformer. The no load loss is useful in evaluating the transformer efficiency. The defects in magnetic circuit of the transformer cause an increase in the no load current and losses and hence reduce the efficiency of the transformer and may lead the excessive overheating, the reducing in lifespan. The check transformer for such defects, its no load or exciting current and losses are measured and compared with the design data. For this purpose, the no load loss and exciting current measurement are carried out. One of the transformer winding, usually the LV winding, okay, is excited with a 3-phase symmetrical 50 Hz voltage. The voltage is gradually raised from 0 to rated value. The HV winding is left open circuited. The active power consumed by the transformer is measured by 3 wattmeter method. Line current are also measured with the ammeter, okay, and voltage is voltmeter. Okay. So this is the theory of no load losses. Now next, load losses or we can say short circuit losses of power transformer. If the secondary winding is short circuited and rated secondary current is circulated, the power input represent total I square R losses in the primary plus secondary winding and also stray losses. Okay. Short circuit test at rated current and frequency gives approximately load loss, also called short circuit loss. Here, this is the transformer under test. Okay, this is high voltage side, this is HV side, and this is low voltage side. Okay, and this is a short circuited current conductors. Okay, so HV side and LV sides. And this is the voltmeter, ammeter, and this is wattmeter. So short circuit test also gives the information about leakage impedance, load losses, impedance voltage of power transformer. The short circuit test, load loss test, impedance voltage measurement are performed during a single test program. In this test, the terminals of LV, okay, this is LV side, are short circuited by means of this is a copper jumper. Three-phase transformer adjustable low voltage is applied to HV winding. The applied voltage is gradually increased till rated current are circulated through secondary winding. Supply voltage is only a fraction of rated voltage. 5 to 10% higher voltage will burn the winding. The measurement of primary voltage, primary current and power input, secondary current are made during short circuit test. With rated current on secondary side, the input power represents total load loss. This is measured and it is adjusted to standard reference temperature 75 degrees Celsius for class A, E, B insulation. The total loss includes copper loss, I square loss, a small core loss. It's 5% of copper loss. The loss measured in this test is useful in determining efficiency of power transformer. The short circuit test reveals the various defects in conducting circuit like a wrong positions of the conductors in the windings, breaks and fractures in the parallel conductors. The use of conductors of wrong section or bad contacts, etc. Okay. Now, insulation resistance or we can say maker. Now, what is the meaning of insulation resistance? How it is measured for power transformer? Okay. Here, this is a current coil. CC means current coil. PC means pressure coil. Okay. And this is a scale. Or this is a pointer. Okay. This is a PC or compensating coil. Okay. This is the magnets. Okay. N and S coil. Okay. This is a generator, dynamo. Okay. This is the ligaments. Okay. This is a contact circuit resistance R. Okay. So here the three terminals E, L, and G. Okay. This is a guard terminals. Okay. This is earth and line. Now, what is insulation resistance? Insulation resistance of an electrical equipment refer to the resistance between conducting part, okay, and earth, expressed in mega ohm. This insulation resistance can also be measured between the circuits separated by insulation. Insulation resistance is measured by, this is a maker, consists of built-in mega ohm meter and a DC generator. The generator is driven by hand or by a motor driven. One terminal of maker is connected to the conducting path. Okay. Other terminal is connected to the earth frame or other conducting circuit. The rotor of the generator is driven by hand or by motor. The reading VDC by IDC, read by the maker, gives the insulation resistance value in mega ohm. The scale of maker is gradually from 0 to infinity. Okay. The scale of maker is gradually from 0 to infinity in terms of mega ohm. When DC voltage is applied to the insulation, initially the insulation draws capacitance charging current in addition to leakage current. These the maker readings. Initially, maker reading is INR 0 equal to VDC by IDC, or we can say IDC is equal to IC plus IL. IC is a charging current and IL is a leakage current. Okay. Now, for good dry transformer insulation at a temperature between 15 degrees Celsius and 60 degrees Celsius, the absorption coefficient KAB should be more than 1.3. So KAB equal to INR 60 divided by INR 15 should be more than 1.3. When INR 15 is equal to 15 second reading and INR 60 means 60 second maker reading. For small or medium transformer, INR 60 and INR 15 gives satisfactory and consistent result for large transformer is 10 minutes and 1 minute reading are taken. Insulation resistance measurement, quality of the transformer insulation and the degree of the dryness. The subsequent high voltage test and commissioning can be avoided if insulation resistance is low. Right? The insulation resistance of a transformer is measured as follows. Between the winding collectively or between each winding and tank, the rest of the winding being grounded. For two winding transformer, between LV winding and tank and HV winding being grounded, between the HV winding and tank, LV winding being grounded, or between the LV HV winding collectively and the tank is grounded. So these are the different types of connections to measure the insulation resistance. For three winding transformer, for measurement are 5 steps. Between HV winding, the tank, the MV-LV are being grounded. Between MV winding and tank, the HV and LV winding being grounded. Between LV winding and tank, HV and MV winding being grounded. And between HV, MV winding collectively and the tank and the LV winding being grounded. When measuring the insulation resistance, a current carrying component part relative to ground. The following procedure can be employed. Two flexible well insulated conductors should be connected to the line and earth terminal of the maker. Okay. The free ends of conductor must have metal terminals with insulated handle. The probe marked grounded should be connected to the transformer tank that must be grounded, and the other probe to a current carrying bar or lead connected to the winding and a test. The maker should be cranked at the speed indicated and its certificate usually 120 rpm, 60 seconds. After the start of the cracking, the insulation resistance should be read on the Megger scale. The value thus obtained is called 60-second insulation resistance and is designated R60 or INR 60. Okay. Or 10-minute reading is taken for large transformer. So when measuring the insulation resistance between different windings, the Megger probe should be connected directly to the windings. Okay. So these are the Megger to measure the insulation resistance of any equipment, transformer, motor, etc. Okay. Thank you.